Hello everybody! Welcome to our video solution to Problem 3 from Quiz 3, Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. In this problem, we start with a finite dimensional vector space, V, over a field F, and we're given a linearly independent list, L, whose length is the same as the dimension of the vector space. So we want to prove that this list is actually a basis. So being a basis means it's linearly independent. Well, we already have that, but it also spans the space. Right? So that's essentially what we're adding here, is if we know the linearly independent list is long enough, then it spans the space. So there are two main ingredients to this proof. So the first main ingredient is going to be that any two bases of V have the same length. And of course, that length is exactly the dimension of V. Okay, so that's our first fact. And the second fact is that any linearly independent list can be extended to a basis, right? So we can add more vectors to the end of it, and all of a sudden, eventually, we're going to get a basis, as long as we do it, smartly. Okay, so any linearly independent list can be extended to a basis of V. Okay, and so now here's the argument. I have a linearly independent list, so I can extend it. Well, how long is it going to be? Well, if it's going to be a basis, then it has to have length dim of V. But my list already has length dim of V, and so I must already have a basis. Okay, so let's write that down. So we extend L to a basis. Right? So what does that mean? That means we're going to add more vectors until we have a basis. But how long will that be, right? Well, we know that any two bases have the same length, namely dim of V. Okay, so we extend L to a basis, meaning, i.e., we carefully, right, because we can't just add any old vectors, they have to make sure the list stays linearly independent. We carefully include more vectors in L until we get a basis. But that basis will have length dim of V. So a list of length dim V. But we already have in L a list of length dim V. So since L has length dim V, this extension process is trivial, right? We don't add any vectors. We can't. Right? We don't add any vectors. Because if we added any vectors, we would get a list longer than the dimension. And so it can't be a basis. So thus, L is already a basis. And there we go. All right, so this is ultimately not a very difficult proof because you're just combining a couple of nice results we have. So the challenging thing is just making sure you can visualize this, right? We have a list of a certain length. We know that if you have a basis, it also has to have that same length. And we know we can extend the green to be a basis, but it's already the right length, so it must already be a basis. All right, hopefully I'm not beating a dead horse at this point too much. We'll see y'all next time.